It's Thursday night. Welcome to LAN Tamer Stream. We are going to do some more multi-protocol, BGP, VPN, v4 labbing. In particular tonight, it's EIGRP. Last night, last couple nights we worked on OSPF. Now we're moving to EIGRP, so looking forward to that. Feeling pretty good tonight. Let's bring up our agenda. Of course, here we have in the background, still in the Star Wars thing, guys. Sorry, I'm going to be there a while. Last Jedi. Go see it if you haven't seen it. If it's available in your country, check it out. Man, it's awesome. I've been reading a lot of different theories about it, and I'm probably going to go see it for a third time soon while it's still in the theater. And just checking to make sure I'm online here. Yeah, online. Good deal. Checking the stream to make sure. This says I'm streaming. This says not necessarily. Yeah, we're all good. So anyway, so tonight, like I mentioned, we're going to talk EIGRP PE-CE routing. And I've got two meat chunks here to talk about. One is a new episode. It didn't come out today. It's been out a few days, a couple days at least. I just got a chance to listen to it. So I'm going to recommend it, though. Good listen. Network Collective, white box networking. Good stuff. I liked it. And again, I don't just spam links here on the agenda and in the description of this video. These meat chunks are links of the day. It should say, links ODD. You know, I tend not to spam those unless I've actually vouched for them, that they're good. I've actually read them myself, and I think that they're worthy of your time. I felt they were worth my time. This is definitely one of them. It was good. Not all Network Collective episodes are good, are going to be meat chunk worthy, but generally they are. They're generally very good, very well done. Also, VXLAN and BGP. I know this is not CCIE specifically related, but I have talked about VXLAN a little bit in the past here, and this is more related kind of to my work, but it is BGP, so eBGP. So yeah, it's, somewhat relevant, but I thought it was a good write-up done in Learning Network, Cisco's Learning Network, CLN. So, but let's get to cracking the whip here, folks. EIGRP PE-CE routing, and we can close this window. I have loaded up the topology. Well, I've not loaded up the topology, actually. I need to do that now. Let me pull in our respective windows here. There's the chat window in case you guys want to chat or say hello or have a burning question about CCIE studies. Feel free to use that. And what else? Yeah, these are the requirements which I've already written out. But I'm going to go ahead and load the user workspace manager. Here, I'm still using Brave browser. It's pretty good. I'm not noticing that it's necessarily any faster. It is good at blocking junk, which is always good. It does a pretty good job of blocking the spam, pop-ups, and the like. All right, so the topology that's called for here in the INE workbook is MPLS, let's see, EIGRP, let's see, there's an MPLS site of origin. That's not this lab. That maybe it'll be tonight. If not, it'll definitely be this weekend, though. But MPLS PE-CE routing with EIGRP, this is a topology you're going to load. So let's go ahead and launch this simulation. This, again, is from the Git repository for INE/viral, which is in the link of the video /stream. Also, just to call out, I saw someone else, and I'm not very good at pronouncing his name, but I saw that he's doing Python programming, network Python programming, and he's got a Twitch channel, which is giving me ideas. I'm going to see how his channel does. Dimitri, and I cannot say his last name. It starts with an F. He's a CCIE, but he's doing Python programming on Twitch. I want to see how that goes because I like the idea of the ability to interact with the community on Twitch is really good. I like you know, and it's not as strict as far as if you pull up a window and play a snippet of a YouTube video and things like that. They're a little more lenient, but he's also uploading videos to YouTube later. So he'll stream on Twitch. I like that idea. Streaming on Twitch and then posting the videos later on YouTube. So that there's still, I don't know how much work is involved with that, but I may explore that a little bit, because the YouTube streaming, YouTube live channel stuff is, I don't know, to me it's not as dynamic and as mature as the streaming platform support on Twitch. Anyway, these are the requirements. MPLS PE-CE routing with EIGRP. We fired up the simulation in Viral. And here are the requirements. For VPN_A, replace OSPF with EIGRP. Now, I don't know if this is feeding off the last lab when it talks about this. We'll have to see what the actual topology loads up as. So I don't know if it's talking about, again, the INE workbook is great. By the way, this is from the INE workbook. I'm not showing it on stream for obvious reasons. If you want to perform this lab yourself, standard disclaimer, download the workbook yourself. It is linked here. For $2.99, you can purchase it, and I think they have a 30% off going right now. So anyway, this lab, it's not always structured. So sometimes they'll put in the description for a lab and say, unlike the last lab you just did, assuming that you're doing them in order, change it this way. Well, that's great as long as the topology is the same, but that we don't know, and sometimes it isn't. So let's actually take a look. It should have loaded by now. Let's go ahead and load up the routers. Router 1, 2, 3, 4, 5, 6, 7, 8. If it's like yesterday's lab, we'll need primarily routers 5, 6, 7, and 8. But let's just see what they look like. Does this mean that OSPF is running as a process and we need to replace it with EIGRP? I doubt it. I think this is just kind of a lazy workbook edit. 170.1.4. Let's look at router 7. Yeah, it might still be kind of booting up, guys. They're showing green here. The nodes are green. These are still building, so yeah, we're still kind of fresh here. It's going to take a second, but let's pull up the topology anyway, the topology map. So you can see we'll kind of map out what's going on here. So if it's anything like yesterday, we've got our cloud here. This is going to be our cloud. Let's redo that. Hey, that works. This is our MPLS cloud. And we're going to have router 6 is going to be the PE, and router 5. These are going to be PE routers. And they are going to neighbor with router 7 and router 8 in EIGRP. So let's do that. Let's indicate that here. I think this is all going to be the same AS area, which is going to be, should be in the same AS. So thank you. I know you're going to actually let us choose the AS number. How thoughtful. And then 5 and 8. Yeah, these are all going to be EIGRP AS. Same AS. Primary patch MPL. Okay, so it looks like we are going to have a backdoor link here, and it's probably going to be the same as the last lab. If that's the case, it'll be this. So we will have a link here as our backdoor. Yeah. And what they want us to do is prefer, yeah, primary path should be through the MPLS cloud. If it is unavailable, then we'll use the backdoor link. So this will still be a valid path in our topology. So yeah, that is our configure. That's our overall idea of what we're working with here. Let's see how the router is coming along here. Low router set. Let's see. All right, let me double check my numbering scheme here. Router 7, 17014. Let's do 16.161.39. Connected to viral escape. Yeah. Okay. Yep, that's us. Okay, still booting up. Yeah, I hope everybody's having a good Thursday. We got one more day of the work week. Then we'll have a nice long weekend. At least I do. I'm off on Monday, which would be nice. It's we get off one day for New Year's here in the US, generally. So look forward to that. Get some fireworks. All right, routers are coming up. So what I'm going to use for this is a document. This is my first time doing this, right? So, you know, we'll see how much I could do from memory. But I went to the configuration guide, IP routing, EIGRP, and this was under EIGRP. You know, in the past, we've been looking somewhat under configuration guides, MPLS, but this, I actually found this under, yeah, now this is VPN PE-CE site of origin. We're not doing that right now. Yeah, so I may have, take back what I just said. To do this configuration, we actually need to go to the MPLS section of the config guides. And let's see, basic, and we do, yeah, L3 VPNs. And here we should have examples, like, here we go, support for EIGRP between PE and CE. So, and there's configuration examples here. And this is basically what I'm going to apply. Hey, we got a message. Hey, I understand, man. Demetrios, thanks for sending the good, hope you're sending the good bits. And D-Day is 31/17. Oh, man, Cisco Live. Yeah, rest up, man. Get your rest. Get that rest. Because you need to be well-rested, well-fed, ready to go this last month, man. Good luck. Good luck, Demetrios. Great support of the stream. And fellow hardworking student there. He's going to Cisco Live and wow, yeah, trying to get my formats right. January 30th. Says 31/18, I guess. Yeah. All right. Awesome. Yeah, it looks like we're both going. You may know if you've been following the stream, I'm actually have verbal approval so far, at least just verbal approval, to go to Cisco Live Orlando 2018. So it's on my bucket list. It's on my bucket list. May actually finally happen. So, all right, router 7. Let's see what it looks like. Looks like configuration is still being applied. And show run section OSPF. Yeah, when these routers on viral, when they first boot up, you know, they're still kind of congealing. They're very slow typically in the beginning. You see, you got these traceback CPU hog messages. All the route, it's kind of like, you know, in the morning. You know, if you've ever done work with domain controllers and Active Directory, and you see everyone logging in at once, downloading group policy, running through, it's a pretty big hit sometimes first thing in the morning. Or on Citrix, you know, Citrix has a big hit. It's kind of like with these routers when they boot up, all the routers boot up, all 10 routers and 4 switches boot up at the same time. You get this kind of, yeah, CPU hog. And that's why usually I kick off. Usually I'll kick off the viral server well before the stream starts, but I just didn't have time today. But let's see, show run section OSPF, see who answers first. Okay, so OSPF is running. And it should be. OSPF is part of our MPLS cloud. That's the IGP running in the MPLS cloud, which is fine. But this looks like our neighbor. Yeah, so let's show that again because it got the console messages gunked that up a little bit. So we got router OSPF 1 network. Okay, so our job here, we have been commissioned. Our mission, if we should choose to accept it, which we have, is to replace OSPF with EIGRP. Okay, so that we know to do already. Let's open up our scratch pad here. Configs. And we're going to do first things first. We're going to tear down OSPF. So that means on router 8, for example, we're going to do no router OSPF 1. Simple enough. We're also going to need to do this on router 7. And we'll also need to tear this out from VPN-A on the PE routers. So let's look at router 5 first. Telnet, telent. And let's just see what we got here. Show run section OSPF. Yeah, it's still low. Okay, so it has the entire configuration. It's got everything in here from the last lab, which is interesting. Yeah, so wow, it's even got all the sham link and everything. All right, so starting here, basically router OSPF, we're going to take this out. This is going to be router 5. And we're just going to take that out right there. No router OSPF 100. Yeah, this router OSPF 1 instance. Now, what is this here? Redistribute OSPF 100. Hold on a second. Oh, that's under BGP, I think. Show run. BGP. OSPF. That's what I should be doing. I should be doing these. So here it is. So under this address family, IPv4, right? Router, BGP, what is it? 100. Address family, IPv4, VRF VPN_A. We're going to take this out. I mean, it doesn't matter. That's just to be clean, right? We want everything to be nice and shiny when we're all done. Ugly, dirty, and functional is okay too, but, you know, nice and shiny is also good. Good for our sanity. I'm going to assume this is the same over here. Let's just look though. Show run section OSPF BGP. Router OSPF 100. That's right. VPN_A. And that's going to take all that out. Then router BGP 100. Address family, IPv4, VRF VPN_A. Yes, same thing. Okay, good deal. All right, so that is ripping out OSPF. Then what we want to do is just come back in here, replace it with EIGRP. Now, EIGRP is a little different from what I remember. I want to see how much I can do from memory without looking at the guide, which may not be much. But router 7 and 8 are gonna be easy. Because all we're going to say is router EIGRP, let's use 100. network. Yeah, let's just do, and that's it. That's all we need here, right? Oh, we do need to, nope, that's it. That's all we need to do. We have to create, I guess the backdoor link is already up. If we look at the backdoor link, which is going to be between, I should have just made this full screen, which I'm going to do now. So this, I'm assuming, is GIS 0178, but let's make sure. Show run interface GIS 0178. Yeah, it's configured. And notice the OSPF cost. So just because we want to be clean, we're going to take that out as well. And we're going to say interface GIS 0178. No IP OSPF cost 9999. So we're going to do that on both 7 and 8. We're going to change the cost for EIGRP, but all in time, my friends, all in due time. Oh, and I did make an evening cup of coffee here to get my spirits going. I did go to the gym today. Did not get my behind beaten as bad as it was yesterday. I'm still hurting a lot from yesterday, but anyway. Is going to help us going for our evening labs here. All right, so let's that takes care of EIGRP on router 7 and router 8, and we're just going to go ahead and preemptively let's just go ahead and do it. IP EIGRP cost. Actually, there's a different terminology here, isn't there? Interface GIS 0178. IP EIGRP, yeah, there's a, what do we want to do? We probably want to add delay here. So, show interface GIS 0178. Yeah, right now it's 10 microseconds. So we're just going to make it something crazy like, let's do it what a loopback would be, which I believe, let me think about this. For EIGRP, what is a delay? What is the standard delay of a loopback interface in our environment on these routers? And I believe it is 1,000. Let's see. Show interface L0. 5,000 microseconds, not 1,000. Okay, let's just do that. So what we're going to do here, and that's why I came down to the interface to be sure. We're going to say delay is 5,000 because we're going to have this path, but we want to prefer the MPLS cloud, right? So anyway, those are our CE routers. I don't think we have to do anything else on the CE routers. Yeah, I don't think we have to do anything else on the CE routers. Now let's go to the PE routers. And not a whole lot different here, I think, than what we would do with OSPF. We have to do address families in EIGRP instead of just the number. So let's see, I'm going to have to venture to the command line here. Again, I'm trying not to look at the config guide. So let's just go ahead and put this in here. Let's just go and do that. Okay. And I believe what we want to do is say router EIGRP. We could do named instance. I'm going to do classic for right now. I'm going to do classic, and then you know what? Let's do this because we're adventurous souls. Let's do on router 5. We're going to do on router 5 to router 8. We'll do classic EIGRP, and router 7 to router 6. We'll do named EIGRP. How about that? So over here, we're going to do router, and I think router EIGRP 100. Yeah, I think I have to do it like that. And then I have to say address family IPv4 VRF VPN underscore A 100. Yeah, I think that's all we have to do there. If we're going to keep the same, what are our options here though? Exit address family. What if we just do exit? Huh, it won't let us do exit address family. Warning, EIGRP addresses must be provided. Okay, address family. VRF VPN underscore A. Specify address family autonomous system number. And we're going to do the same. Actually, you know what? Let's do it differently just to distinguish. And I think this is what I remember from the video, and I'm going off what I remember from the video here. So this major process number is arbitrary. It doesn't matter. But we have to put our address family VRF autonomous system configuration below the global. So the global in this case doesn't really matter from what I understand. And I'm making this statement with a lot of authority like I'm 100% sure, but I'm not. But that's what we're going to say for right now. So now we can do address family, IPv4, autonomous system. No, I need to do VRF. VRF, VPN A, autonomous system. And yeah, 100. Okay, boom, there we go. And normally I would work out of Notepad here or the Mac equivalent, but I want to get used to typing this out. By the time I am ready to sit for the exam, I need to know this without having to hit question marks so much at the CLI. I need to be able to essentially recall this from memory. So more practice, the better, right? You know, and I balance that with practicing becoming effective in, and I'm diverging a little bit here, but let's talk strategy a little bit, right? So, because these are the junction points where it's good to reflect on strategy for the lab. So in sitting for the lab, I need to be very proficient at using Notepad, but I also need to be very proficient at recalling from memory the commands that I need to use in their context. So while I'm labbing right now, I want to be able to become proficient as much as I can in both. Now I'm only going to become so, you know, efficient to a certain degree doing the individual technology labs. Where this is going to come into play, we're going to get a lot of practice, is once I get through with all the workbook, and I may do another workbook, and I start labbing full labs. In that case, I'm going to need to be proficient at both, right? So anyway, I'm going to switch a little bit back and forth here, getting back to the lab. So we're under address family, and this is where we specify our network. And we're going to say, in this case, under this VRF, we're just going to do everything. Okay. And we should get an adjacency now. Oh, I haven't done router 8 yet. Yeah, that's right. I've put it in here, but I've not put this in router 8 yet. So let's go ahead and do that. And there we go. New adjacency. Good deal. So now let's just do a little bit of verification. Show IP EIGRP neighbors. Yep, we have 151.58.5, GI0158. And show IP EIGRP topology. Should have actually learned some routes now, right? Which we have from our PE router. We see we are in AS100. And most of these are connected, right? So yeah. But this is via this interface, so we've got a couple of routes that we've learned from our PE. Okay, but nothing's going over the cloud yet, right? Yeah, nothing's going over the cloud. And we don't have an adjacency through the backhaul link or the backdoor link yet because we have not yet configured EIGRP on router 7. We're about to do that though, and we're going to go over here, and I'm going to change this because we want 7 to 6 to be named mode. So let's do router EIGRP MPLS. And we're going to say address family IPv4 autonomous system 100. Yeah, that's really what we're used to typing, right? So it's interesting that in classic mode, when we do a VRF, it looks very similar to this format that we're used to in named mode. But of course, it's different, right? All right, so that's all the changes we need to do there, I believe. So let's go head over to router 7. And we got a neighbor adjacency, right? Show PE-EIGRP neighbors. Show IP-EIGRP topology. Good. All right, so we got some good things going on here. Now this is just purely EIGRP. We have nothing going through the cloud yet. But let's go over to router 6. And we're going to take out OSPF first. And we're going to configure EIGRP now to the VRF in classic mode. So this is going to be router EIGRP. And this is, again, locally significant only. But address family IPv4 autonomous. This time we need to do this, right? VRF _A autonomous system 100. And want to do, again, network 0.0.0.0. Done. So we should get an adjacency here. Router EIGRP, address family IPv4 VRF VPN _A, autonomous system 100, network. Yeah, I don't see my adjacency yet. Show IP EIGRP. Yeah, got nothing. Show IP VRF. Okay, VPN _A, J0167. That's right. So he should be seeing router 7. J0167. Oh, it's administratively down. And why would that be? Screwing with us, man. INE. Mess with us. There we go. Sneaky, sneaky. You aren't going to believe this, folks, but my wife, for the first time, just saw... We binged the Lord of the Rings trilogy. And so now she's saying, my precious. And this is coming to mind now with INE sometimes. Tricksy they are. I can't do the voice. Don't ask me to. But anyway, very tricksy right there. The old shut down the interface. All right, so now we're talking. We have a full mesh with the exception of the MPLS cloud. So that is the next thing we want to configure. One thing I want to check, though, is show IP route EIGRP. Any routes that we're learning across the backhaul link, which is several. Okay, look at that high, look at the very high metric there. That should definitely not be preferred once we learn it over the cloud, I wouldn't think. Yeah, good. Okay, now let's configure the redistribution. So this is where we need to come into router 5, for example, and we need to go into our router BGP 100, address, family, VPN v4, unicast, and we need to redistribute. Actually, yeah, I need to go into the address, right? This is under IPv4, right? Because remember, the VPN v4 is going to be the cloud side, the cloud adjacency. The IPv4 address family is our CE side of things, right? So we need to come in here, router BGP 100. I think I'm already there. Address family IPv4. VRF, VPN underscore A, redistribute EIGRP 100. And I'm not sure if I need to put a metric here or not. I don't think I need to. I believe it will use defaults. And I'm going to be lazy there, but we need to come into EIGRP as well. And we need to say router EIGRP. And here it is, classic mode. Address, family, IPv4, VRF, VPN underscore A, 100. Autonomous system, sorry. SITM. Yes, I know that. Show run section EIGRP. Yeah, I have conflicting numbers here. I think I did this as 1, yeah. No router EIGRP 100. Router EIGRP 1, address, nope, not 10. Router EIGRP 100, address, family, IPv4, VRF, VPN underscore A, autonomous system, SITM. Oh, come on now. What am I doing wrong? Not sure how that happened. I didn't remove it last time. Router, EIGRP 1. Address, family, IPv4, VRF, VPN underscore A, autonomous system 100. Thank you. Redistribute. What's our BGP? Do, show, run. What's our AS number here? Okay. Oh, right. Yeah, I am the PE router. So, of course, it's a redistribute BGP 100. Okay. All right. So now we should see routes going into and out of the cloud on one side, but we need to configure other side as well. Let's do that here on router 6. So first we'll go to router EIGRP and its MPLS, address, family, IPv4, VRF, VPN underscore A, autonomous system 100, and redistribute. Actually, I have to go to address. Topology base. Redistribute BGP 100. Yeah, there we go. And we have to go into BGP, router BGP 100, address, family, IPv4, VPN, VRF, VPN underscore A, redistribute EIGRP 100. Yeah. Okay, so now we should have it on both ends. So let's see what we have here. Show IP. Let's go to router 7. Show IP EIGRP. Show IP route. Okay, there we have it now. Some of these routes that we were learning earlier through the backhaul link, we are now learning them through the MPLS cloud, which is good. And let's take a look at that. What's really cool is the extended community attributes in BGP, how BGP is able to carry all those metrics and AS information and all that across in the BGP update messages. And we can see that here if we do show BGP address family VPN v4, actually show VPN v4 unicast, just VPN v4. I need to get more familiar with this. Show BGP VPN v4 unicast. There we go. What did I do wrong here? VPVN 4. Okay. And then all. And then. Yeah, let's just do that. Well, no, let's do VRF VPN underscore A. Yeah, so route distinguisher 100. And then can we see? Yeah, let's look at a specific route. So let's go over to router 7. And we see we're learning, on router 7, we're learning router 8's loopback. So let's see what that looks like here on router 6, actually. Show BGP VPN v4 unicast. And then let's do, what did I do? BGP. 150.1.8.8. Yeah, look at these. This is cool. This is good stuff. Actually, I'm going to bump this up because I want to screen cap this. So here we're learning. We have one available, one path, not advertising appear, local. And of course, this is going to come from 150.1.4.4, which is our route reflector in the MPLS cloud, right? Origin incomplete because it's redistributed. Here's the metric. Valid internal best. And here's extended community stuff. So cost pre-best path is 128. And I learned today that this is how BGP distinguishes. It needs this information because it's going to evaluate an EIGRP route from BGP and from other EIGRP neighbors. And it's able to compare apples to apples because here it's going to see this best path. There's a type 128, which is internal, I believe, or no. Let's look on router 8. Or actually router 5. Show IP EIGRP VRF VPN A topology. Feasible distance. Here it is, distance of 90. Yeah, internal. So that what that looks like on this side is 128. Then we have metric. I believe somewhere in here the information is AS number, the MTU, all the metrics, the distance, the composite metric. I believe that's what that is. Originator cluster list. Yeah, good stuff. Good stuff, guys. All right. That's what we expect then. And what I want to do is do a packet capture. because I want to see, I mean, that's basically showing us what it looks like, but let's go to router 5. And what we're going to do is we're going to bounce this link, because that is part of our requirements, right? We're supposed to be able to demonstrate that the backhaul link will become usable. I think we're going to get a query on here. I want to see the query packet and reply. So let's just capture everything here on router 5. And what I'm going to do is, let's see, router 5. Yeah, just kind of for fun, I'm just going to shut down the link, because we want a fast convergence here. So let's shut down show IP. Our link to the MPLS cloud is going to be show BGP. Actually, show IP route OSPF 45.4. Yeah, that's what we're using for our right. So let's shut that interface down. Well, let's start a ping first. So we're going to do a ping from router 8 to router 7's loopback. Right now, it should come across the MPLS cloud, right? Trace route 150.1.7.7. There it is. See, it's going across the MPLS cloud. 1, 2, 3, 4 hops. So let's run a continual ping. And then let's shut this interface down on router 5. Okay, we should load some packets here. Due to convergence, right? So, and there we go. So EIGRP converges pretty fast. And then let's do a trace route. Trace route, same trace route. Should not be using the MPLS cloud unless we have multiple routes to that. Router 5 and then router... Yeah, how is that possible? Oh, okay. Router 5 has multiple links into the MPLS cloud. So that was an even more interesting... let's shut that down too. That's going to be interface GI0, 1, 100. So now if we do this... Yeah, he's going to try to go to router first because we have not converged. We have not reconverged. But we should get this in a second here. There we go. Now we've converged. And now if we do a trace route, we should be going, there we go, across a backhaul link. Very good. All right. So it worked like we expected. Now let's go ahead and put everything back because I want to see those update packets in our capture. So interface range GI0 145, GI0 1 100. Okay, it doesn't like that. Interface GI0 145, no shut. And we should see this. Let's just watch this. Yeah, we're good to go. Yeah, still a little convergence going on, but we're going back across the MPLS cloud. So that's what we want. Good stuff. And if we do a show IP route, as you can see here, we're going to router 5 to get that. The route metric is 3104. Total delay 22 microseconds, which is pretty large. Or not pretty large, it's pretty small in comparison to what we have the other links set to 2 hops. Good deal. Good stuff. So it wasn't too bad. Pretty good lab. Let's look at our packet capture, guys, and look at the pretty packets. We love to look at the pretty packets. In particular, what I want to look for is the cool extended community stuff. And I did not have to use this config guide, which is cool. Of course, a lot of this was already built for me. Oh yeah, let's look at our capture. I already posted, folks, if you're not familiar, if it's, I realize it's mostly useful to me, but on the Google Drive for the channel, which is linked in the description, I do post the, where did Warshard go? It's still loading. I do post the captures from these labs. So yesterday's was already posted if you're interested, or, you know, sometimes you just might not have time in your life in this very moment to be labbing due to work, or, but maybe you're listening to this at work, or you're listening to this while you're doing chores or something else. But you say, hey, you know, I'd like to actually go look at those packet captures that Landtamer did on the stream. You could go here, the shared drive, the captures are all shared, sort by date or whatever you want to do. But yeah, these are the OSPF sham link. That's a capture from yesterday. So I'm going to leave that open because I'm going to post this one later. And it has not opened yet. Oh, I only unzipped it. Durr. Okay, here we go. Yeah, what I really want to look at here is the, from router 5, I want to see the VP or the BGP update message with the extended community. So what we're going to do here is going to say TCP port 179 and IP source is 151. Actually, what interface would that have been? It'd be 45.1.45.5. I believe that's it. What happened? Maybe not. Well, let's just look at our BGP messages. Oh, these are coming from the loopback, right? That's right. Yeah. Well, there aren't many here, so we should see keep alive, keep alive, keep alive update. And this will probably be a withdraw. What I want to do is see when this interface came back up. I want to see the update and what that looked like for one of these. Well, let's pick router 7's loopback. So this is going to be an LRI. You have to really dig to get to this. All right, that's not the one we want. Let's look at, which one did we just look at? This one? An LRI. BGP prefix. 1515.0. We don't care about that one. Let's look at this first one here. This one's good enough. So 78.0, and we want to see some of the attributes of this particular update. So we have extended communities, and we should see carried extended communities. And here's all of your EIGRP information, all the EIGRP goodness bundled in here. There's a cost, POI, and I was reading about this, and this is going to come into play in the next lab we do on stream here, which is going to be site of origin. So we won't get into this a lot now, but we'll learn on what that POI is. And then we've got the normal stuff we're used to seeing for an EIGRP update message, which is the delay, the AS number, Reliability, 255, right? Well, we have reliability, hop count, bandwidth, 255, 1, 2560. 2560 is a bandwidth. MTU, load MTU, 1 in 1500. Originating router, 1's216, 8.8. AS number delay, 100 and 1280256. And these are the route tags, or route flags, route tag, yeah, internal route. We're going to learn about that some more tomorrow on site of origin. But here we go, extended communities, so good stuff. And I'm going to capture this for our... I like to put this stuff, you know, post these on Twitter and stuff. So here's our extended communities. And I'm going to kind of highlight this field. So good stuff. Anything else we want to look at that I can think of? So this traffic we would expect, right? If we sort it by protocol, we've got our LDPs. Let's go all the way to the top. Captured quite a while, so we're going to see a lot of ARPs. And then we should see... I just like to browse. You ever just get in the mood just to browse a PCAP, right? Just for fun. Just out of curiosity, just look under the covers. So ARP, BGP, CDP, we already looked at BGP, DTP. Naturally, we've got EIGRP. So a lot of hellos, reply. Here's a query. So this is the query that we saw. Who's this coming from? Router 5, yeah. So as we know, at some point we shut some interfaces down, and router 5 is like, hey, now I need a query for these networks here, right? So this is a opcode 3 EIGRP query packet. And then we should have a so here's a reply. Looks like he replied to himself. Does that make any sense? That doesn't make a lot of sense to me. I don't know why he would do that. Oh, no, he didn't. This is router 8. Yeah, router 8 sent a reply. It's like, I got you, man. And this would be a reply because I don't think these routes would have even been feasible successors. So after 8 sent a query, he would have gotten a response over the backhaul link, and then 8 would have replied to 5. Yes, I have these routes. Said, hey, I got you, man. Got you covered. So like here's him saying, I have this loop back. And this is an opcode 4, right? So we expect to see some of that going on. And then we have some more queries, updates down here. All good stuff. What else are we looking at? ESP. Yeah, because we have a tunnel. We've got some pings. Some OSPF. That's our IGP in the cloud. RIP v2, I don't even ask. I have no idea. And UDP, I don't know what these are. I don't recognize these ports. Oh, trace route. Okay. Interesting. Possible trace route. So this is MPLS traffic, right? Trace route through the MPLS. I'm assuming that's what that is. And that's it. That's our capture. All right, folks, I think I'm going to wrap it up here. We had a good lab. Let's just review what's coming up. This is also in, this checklist is also in Google Drive. Right now we are 52.94% done. Completed 225 labs, 200 remaining. I'm beginning to wonder if that's actually updating. We'll find out right now. So PE-CE routing with EIGRP was tonight. Tomorrow we will tackle the site of origin. I have a little more reading to do on that. And it looks like, oh, BGP has an SOO as well. Then internet access and performance tuning. Okay. All right. This is updating. Yeah. 199 remaining. We're 53.18% done with the INE workbook. 210 lab days remaining. 7 months. So in 7 months, we should be done with this workbook at the rate we're going. That does not account for practice labs, you know, retakes, holidays, things like that. But yeah, we're going to try to catch up. The next section is going to be interesting. IPsec VPN. Then we have multicast, IPv6, QoS, security, system management, IP services, and then we get into the fun, the big labs. Good stuff. We will keep on trucking here at LAN Tamer Stream. Thank you for joining. Please select the like button if you enjoyed it, and subscribe if you haven't already. You can click the little alarm button to see anytime the stream, to get notifications when I go online. And thanks again, folks, for your support. Keep on labbing, keep on learning, and we shall see you back here in the LAN Tamer Stream. Tomorrow's Friday. That is usually my off night. I don't know. I may do a lab because I've kind of had a good bit of time off. If not, we'll see you here on Saturday, and we should be doing a lot of good heavy labbing on Saturday. Hopefully finishing out MPLS. All right, thanks, folks. Have a good night, and we will see you soon back here in the stream.